far we've been looking at differential equations in one variable only and integrating so we can get y equals as the subject. These examples that we're going to look at are functions which have both x, a function in terms of x, and a function in terms of y. And we're going to use a technique called separation of variables, which is very, very similar to what we've been doing already in differential equations in order to solve these types of equations. So they're much more complicated, as you would imagine. But in terms of the process, it's exactly the same. And when I say complicated, I mean only in terms of what they look like. In terms of the processes, there's no complication at all. So let's have a look at a couple of examples this morning. The first one is solve the differential equation, dy dx equals e to the 2x, and then 1 plus y squared. So as you can see here, we've got a function in terms of x, and we've got a function in terms of y. And eventually what we want to try and do is get all the functions in terms of y with the dy, and the function in terms of x with the dx. And so we're going to separate the variables out. So we'll start with rewriting the equation as usual. And this one's already basically separated into its two separate functions, so we can do that quite easily. So we're going to have the dy function on one side and the dx. Well, we'll just leave the e to the 2x exactly where it is. Don't have to change it at all. We brought the dx up to the right-hand side, and then we're going to move the 1 plus y squared to the other side of the equation through division. Nothing different there. And then as per usual, we just integrate both sides. Now this time we've got two functions that we integrate separately. So if we look at the right-hand side first of all, so the right-hand side of this equation is the integral of e to the 2x dx, reasonably simple integral, so it's going to be e to the 2x, so it's a half e to the 2x plus c. If we look at the left-hand side, and the left-hand side is a little bit more complicated, but not a major amount, 1 plus y squared to y. And if we can look at that, hopefully you will recognize one of our trig integrals, our formula sheet. There it is. So if we look here, we should recognize the integral towards the bottom here, the a over 1. So a over a squared plus x squared is the integral. So the integral of that is tan to the minus 1 x on a. Well, in our example, we've got a is equal to 1. So if we think about, so our integral is actually the integral of a on a squared plus x squared dx is equal to tan minus 1 x on a. So that's the relationship that we're going to be using. In this particular case, a is equal to 1, so that's going to equal tan minus 1 y. So a is equal to 1. Okay, so there's my two integrals. So now I come back to here, back to my actual equation. Tan to the minus 1 of y is equal to 1/2 e to the 2x. We have plus c. Now, again, like we've done in the past, we only really need one integral constant. So that obviously there's an integral constant in both sides of the equation. But because they're both constants that we don't know, then I can create one master constant, if you like, where it's just the sum of the two integral constants that we've found on each side. So now we've found that, we now have to express our function in terms of y. So that's going to be tan of 1/2 e to 2x plus c. And that's our equation in terms of y. Okay, let's look at a second example. Okay, so given dy dx equals sine squared x over y squared, and we're given a value, so this is going to be a bit of a hint that we're going to need to find what our c is, and find an expression for y in terms of x. So once again, we'll start with our equation. Dy dx is equal to sine squared x over y squared. Separate the variables, so I'm going to have y squared dy is equal to sine squared x dx. Alright, so once again, let's look at our two equations. Let's do the left-hand side first because it's a little bit easier. Alright, 1 squared dy. That's just going to be y cubed over 3 plus c. Nice and simple. Right-hand side is going to be the integral of sine squared x dx. Now, do we recognize any relationships that we could possibly use here? Well, let's go and look at our formula sheet and see if it gives us some inspiration. Okay, so are there any integrals there? No, there's no sine squareds anywhere there. So let's have a look at our trig identities. scroll down a bit, there's our trig identities. Do we have any trig identities here that might be helpful to us in terms of our integrals? Well, we want sine squared in the identity, but we want to be able to integrate it. So what we're going to probably use is this cos 2a equals 1 minus 2 sine squared a, and we'll rearrange it. So if I put my formula back up, so the relationship we're going to look at is cos of 2a is 1 minus sine squared a. So that's the relationship I want. Okay. Now, given that, let's have a look. Oh, sorry, it's a 2 sine squared. That's right. Yep, sorry about that. So I want sine squared, so let's get it by itself. So it's going to be 2 sine squared a is equal to 1 minus cos of 2a. Just check this negatives, but I'll just swap them over, so that's fine. And then so sine squared a is going to equal a half 1 minus cos of 2a. All right. So there's my integral. So that's come across. That's going to be the integral of. So I'm going to bring the half out the front. So 1 minus cos of 2a. Oh, so it's obviously going to be 2a. It's going to be 2y. Oh, no, it's not. It's 2x. 2x. So that's going to be a half multiplied by. So integral of 1 is x minus integral of cos 2x is sine 2x over 2 plus c. Okay, so let's go back to my function now. So let's put our bits of information in. I'll just box that off so we don't get confused. So we're going to have y cubed over 3 is equal to 1 half x minus a half sine 2x plus c. Once again, I'm just going to keep my 1 plus c. Okay, let's leave that as for the moment. So we want to work out what c is. So we know that at 0, x equals 0, y equals 1. So we're going to have 1 cubed over 3 is equal to a half. 0 minus a half sine 0 plus c. Okay, and we can have play around with that, but basically the left-hand side is equal to 0, sine 0 is 0, so that's all 0, so c is equal to 1/3. So therefore we've got y cubed over 3 is equal to a half, x minus a half sine 2x plus 1/3. Not real pleasant, but we want to, the question actually says expression for y, not y cubed, so let's finish this off. So y cubed is going to equal 3 on 2, x minus a half sine 2x. You can square the brackets if you want, it doesn't matter, plus 1, because 3 times a third is 1. And then we just got to take the cubed root. You could raise it all to the power of a third if you want to. 3 on 2, x minus a half sine 2x bracket plus 1. Not very pleasant, but that's the solution. Okay, so there's a couple of examples of using separation of variables to find using differential equations. Don't forget that you sometimes need to incorporate some of your other processes. So don't forget to use your formula sheet to help you. If you get stuck, you look at an integral and go, can't have a look at your formula sheet. Hopefully that will give you some inspiration on how to find that integral. There are a few questions to have a go at now from our Cambridge textbook. And if you have a crack at those, and obviously ask any questions that you need when you need to.